This session is about the first step of infrastructure as code, which is configuration monitoring. Many thanks to the sponsors. And I'm David Sass. I'm not supposed to be here because I was supposed to be an attendee as you, but some speakers didn't make it, so I had to step up and fill a slot. I work as an SRE, I scream at the cloud, I hate Git, and I dream the good old days of SharePoint Server 2013 when my only problem was Kerberos, really, nothing else. So why would we need this session when we need configuration monitoring? I think because you can get a new job, new environment, you need to figure out what's going on, or you get promoted, or rotated into a different position, or someone quit and now you inherited their job as a promotion, or it just became too big, the infrastructure itself. You have many data centers, many resource groups, I mean, not data centers, Azure regions, resource groups, and you have no idea what's going on, or you was just told to do infrastructure as code, and that is scary. At least it is to me, and I have been trying to do that for years, and still scares me every day when I'm at work. Because infrastructure as code is a journey, and it has many steps, but I don't think that anyone really ever speaks about the first steps, and that is to monitor and validate the configuration changes, even done by you, done by a script you ran, or when you actually start doing infrastructure as code, you also need to validate that it not just didn't fail, the pipeline, because we have seen some sessions where it was running and it failed, and we could troubleshoot it because the pipeline can success, but it doesn't mean that it actually did what you want it to do, and you need to validate that the output is truly what you needed. And when you have the ability to properly report on what configuration is, you can move to the next step to monitor that the desired state is still there and it didn't drift, and move to the next and the next. So what changes do we need to monitor? Changes come in many shape and size. It can be just ourselves doing something and having unintended side effects, or something legacy running in the system, but you inherited doing changes you are not aware of. It could be just Microsoft Defender doing its fixes, like a storage account has public access enabled, and someone clicks fix it now, and now it doesn't have public access, but that storage account hosted the company website's public resources, and now the company website doesn't work, but you didn't do anything, but people still screams. So knowing what changed and when is really important. And that's the benefit. You know, you can go look at the configuration in a easily readable text file format and look at the history of that text file. When was the last change? Or if you went on a vacation and came back, how many changes happened? You can even compare this way, compare two text files to each other. There are many tools, like VS Code can do it, or the good old Total Commander if you have a license. I love that. And it really helps, especially when you have a global infrastructure and you need to make sure that West Europe is running the same as Australia East. There are different ways to reach this configuration monitoring heaven. It depends on what you need to monitor. If it's Microsoft 365, the Microsoft 365 DSC can help because it can do reverse DSC. Instead of pushing configuration. It can just dump what is configured currently in the tenant or in the tenants. It can do Azure AD and Power Platform, but it cannot do standard Azure infrastructure. So for that, you need something else. Exporting ARM templates is an option. It can help in some cases. I wouldn't recommend it because it's very verbose. Like if it's an Azure App Service, which is being backed up every hour by Azure, and you cannot turn that backup off. In the ARM template, you will get the list of all of those backups going back forever. And that's very much not useful. It also cannot do Microsoft 365, so we always need to mix. I mean, it depends on your goals, if you need to mix or not. Or you can just do Azure CLI that can do Azure and can do Azure AD, but cannot do Microsoft 365. I think that's, and I'm going to focus on the CLI because basically we need two things, the show and the list commands to get the data out. And with that, we can get most things out. And this is the slow slide because that picture is huge. And I can do the demos. The first thing we need is Azure. We need resources in Azure, of course, for this demo at least. I have some resource groups. There are some stuff in them. Storage account, function app, application insights, log analytics. And I have a public GitHub repository which contains the script which is being executed, including the workflow which is executing the script, because I'm implementing with Azure, not Azure, with GitHub Actions. Azure DevOps also works. If you are using Azure DevOps, you can use pipelines, do the same thing. There are some fair warnings. You probably don't want to do this in a public repo at work, and depending on what you are exporting, it can contain secrets. You need to be aware of that because you might not want to check them into source control because you might get that depending on your culture. In the repo, I collected some resources. I'm not going to spend much time on them. In the source folder, I have two reporting scripts. I will spend some time on them in a minute. And in the GitHub Workflows folder, I have a GitHub Action in a YAML format. I will show that as well in another minute. There is a need to have a second repository because whatever is being collected by the first repository and GitHub Actions, it needs to be stored somewhere. And the second repository is a perfect place for it because if I refresh this, every generated output, sorry, wrong button, has its last update time and date shown here. And if we open something, the functions app list, there is this, it doesn't look like a link, but it's a link. If you click that, it will show you what was the change in the last commit. And you can see what was deleted, what was added, or just modified. And this is where you get the benefits. You are told something changed. You are surprised. You don't believe. You go to the report repository. You look at the files. You see that, yeah, it was changed. Okay. And you can look up what changed. And depending on the history, this one only has one version. You can even go back in time and look at previous changes. My pipeline I'm showing you in GitHub Codespaces, the editing experience. This is the YAML pipeline. Sorry, the GitHub Action pipeline is Azure DevOps. We need to check out the source. That's where our script is running. We need to check out the destination. We need some GitHub personal access tokens, store the secrets. We need to sign in into Azure. For that, we need Azure credentials. In this context, Azure credentials means we need not an enterprise application, we need an app registration. It doesn't need any special API permissions. It just needs a client secret, which we can store as a GitHub secret together with the tenant ID and Azure subscription ID. So we can sign in into Azure with that credential, and we can execute the GitHub CLI commands, which I hid them in files. So if I open the report function app script, I'm just running the AZ CLI, and I call the function app and do a list and do some transformation on the results, because I want to use the functions later, so I can get their configuration, I can get their managed identity, and then dump them into their respective outputs. Now, I like this CLI because whatever I do here, I can also do that on my machine, as long as I'm signed in into the same tenant, and I can just paste the command and run it, and I will see the results. And this is, I believe, a very good authoring experience, that you can run them easily on your machine. It's quick. You don't need to wait for the pipeline or the GitHub Action to trigger, to sign in, to collect the information and get back the results for you. You can actually just run these things on your machine, see the results, tweak, and if you like them, head over to the repository, check in the changes, and let the pipeline run. And as you go, because this is, I'm doing this session to fill a slot. I didn't have time to look at how to discover all the existing resources automatically. So I need to create different files for the different resource types. There should be a way to list all resources, and based on their type, call the appropriate show and other commands. I can present that next year. But right now, it's one file per resource type. And if I copy a file and paste it in, I should be able to collect something else, like application insights or log analytics. And in that case, I just need to change a couple of variables here, and that should be fine. I just need to cheat. I believe if I run this here with the show command, I will get results. Oh, I need to define resource groups. I created everything here in this session, so I can use the previous variables. And I'm actually showing you how to do it in real life, because I have no idea what the N workspace name. Oh. Yeah, show is bad because show wants to return you one specific log analytics workspace, and I need all, so I need to use list instead. And yes, there is something returned, so I can grab this, head back over to my new file, and paste it in. For some reasons, code spaces and clipboards work in a very unexpected ways. So I can't use the keyboard shortcut of pasting. So with this, I get all the workspaces, I convert them into objects. So if later other properties are needed, like I did it with the functions app, I can use that variable and look up the exact resource IDs. I can save this, head over to the pipeline, and I need to extend it with this additional file. And if I didn't make any typos, I can just check these in. And that should trigger the GitHub Action. And in a minute or so, yes, while that is running, I want to go back and show you that we can run these pipelines on a schedule, on a cron schedule. This is some Linux thingy. And in the README file, I collected how to do cron schedules with examples. This is being executed every 5-ish minutes. It's supposed to be 5 minutes, but it's not always 5 minutes. Or if I push into the main branch, or I can start it by hand. So that way we can keep it running. If there is nothing changed in Azure, the output of those JSON files will be the same, and nothing will change in the report library. So you can go on a weekend, nothing changed, you come back, you will not see hundreds of changes in the history because nothing changed, nothing to check in, and that is actually, what's the word? An error. So Git would complain that there is nothing to commit and it would fail, and you need to tell that, yeah, I want it to fail because that's success in this context. So don't properly error out. And if I look up something from the night, or yeah, because it was running the whole night every 5 minutes, so 10 hours ago, it succeeded. That's why we have the blue check mark, but there was that error which was ignored because there was nothing changing. And if I come out, it completed. It actually completed twice, once for my change, once for the schedule. And if I refresh the report library, the function of config, that's 1 hour. Workspace list is here, a new file, and everything is in it. Now there is one pitfall we need to deal with, is that not all change is a real change, and sometimes the modified date changes, and only that, but that also creates a new file in the report library, and that's unfortunate. I don't have a way currently to deal with that. I have a feeling if we look at the scripts, we can just say we delete that property from the object, and that's not stored anymore and would not give us false changes in the report library. And then we can rely on more. And yes, I did not do function app configuration. Well, I did config. That's function app config is like configuration as I need to check actually. Oh yes, like if it has command lines or default documents, network restrictions, load balancing, etc. It doesn't do app configuration entries. So if I find that function app and it's here, these configuration entries come up. The app settings, application settings, that requires a different command. And this is where we will have those secrets situation, because function apps require storage access. And if I open this, there is an account key here, which is the primary storage account key for this storage. You don't want to check this connection string into source control. So when you do application settings, you need to filter these settings out or replace the account keys in them, because you end up exposing. Or if you can convince your application teams that they can switch to managed identities and use managed identities to connect to storage accounts, assuming that is supported, you can maybe delete these connection strings and or the credentials from them, and then you can check them in. And I am in a real life situation where we run multiple Azure regions with everything its own storage accounts function app. It could be useful to compare these things depending on what other entry is here, like if it's a Azure SQL connection string and there is a port in it, and you want all SQL servers to have the same ports, you might want to compare that the connection strings have the correct port in them, but you want to ignore the passwords in the connection strings. So that requires special care, and you want to play with those in your machine first and not in a pipeline, because yeah, if you check them in, you need to rotate them. What else? I need to look at my cheat sheet and I will be ready for questions. Oh, the permissions. So I showed you the app registration, but I didn't show you the actual settings I had to set. I did that on the subscription level and assigned a role assignment, a reader role assignment to the app registration, and that is all what is needed. It doesn't require anything like contributor or something to change things, only reader, and that's enough to get most things. There are some special cases like key vault secrets. If you want to monitor key vault secrets, their existence, not their actual secret content, you can also do that. And in that case, if you have different files for different environments, you can really just compare the secrets to each other, that you have the exact amount and the names are matching. Yeah. I think I saw a question.
Yes. Would it be possible to change this unwanted parts of the JSON with only 5 hashes, so you can compare it, but you don't see the real value?
So the question was if we can somehow change those secrets in the configurations to maybe a hash or something, so we can store them and compare hashes and not expose the actual secrets. That's actually a great idea, and yes, I would actually recommend that, because in that case you can hash the full connection string as it is to MD5, and you can compare the MD5 hashes that they didn't change. Yeah.
So you will see it has changed.
Yes, you see the change, but you don't know. You don't expose.
Yeah.
Yeah, great question. If I would have more time, I would probably figure that out on my own. Yeah. I think that is it.
I have a question as well.
Sure.
So all these configuration files, it's great that you can go back and find out what changed, but are there any way you can graphically show when big changes had happened, or so when a user comes and says there's been a big change, you can go back in history and see, okay, and on that day, that was a big change in the configuration, instead of digging into each file?
So the question was, is there a way to show when many things changed? Because someone did a big change and there is a huge list of files changed in that time. Maybe I'm using Git as the repository for the reports. I think Git can do that. I assume, like, somehow. I never researched it.
It can be done.
But I hear that it can be done.
Yeah. So what we use a bit the same, but only for monitoring Microsoft 365 with IaC. And what we do, we create a new branch with where things are changed, and we commit that to the main branch with a pull request. And in a pull request, we set the commands and everything that's changing, and then you have just one. Yeah, you can see.
So for those who watch the recording later, the answer we got from the attendees that if we check in the reports into different branches every time when there is a change, and we create a pull request from that branch to the main, the pull request will show us the summary of changes, how many files changed, and that helps us to monitor when something big went down in the environment. Great, thank you. And I wanted to talk a bit about the pitfalls. I mentioned that ARM templates are very verbose already, and not all changes are relevant, or not all properties are relevant, and we need to filter those out. There is one other thing, that you really need 2 repositories for this. I tried to implement it with one, and in the main I had the GitHub Action, and I was checking code into another branch. But the pipeline had to switch between branches, and it became a mess, because when it changed, the files changed because the other branch didn't have them. So don't do it with one repository. You need to. You will be happier trying to implement this. And basically the main resource, if you need, it's the this repository where I have the pipeline and the scripts. It will be updated later to reference the report library. You can look it up. I will disable my secrets, so it will not run anymore. It will stay as it is today. And all of it will also be uploaded into the conference GitHub repository later, next week. And with that, if anyone has any more questions, and I'm kind of on time with the demo and the presentation, you can have those extra questions.
I have a question. Instead of using a repository, but love to store all the information, could you push all this data into a monitor?
So the question was, instead of storing the output in a repository, can we push them into a monitoring tool of some sort? We can do whatever we want with them. If your monitoring tool can process the information and present you in a useful way, sure. Basically, the pipeline is a script. That means code. What you can code, you can do it with it, as long as you manage to do the authentication properly. So yeah, why not?
Have you thought about using activity logs or deployment logs from Azure into this?
Have I thought using deployment logs or activity logs from Azure to mix it? I did. Like, it would be nice to know when a change happened, what actions happened before that, because this runs every 5 minutes. So there is 5 minutes there to implement the changes. I believe it would be possible to query the audit logs or activity logs as well and get who did the change, and also store it somehow. If we go down on the different every change a different branch situation, and we create pull requests automatically with the pipeline, we can populate the pull requests with information who did the change. And yeah, I was time limited. Anything else? Thank you.